So how do we collect drug evidence and test it? Here we get into a lot of what we're going to see at the crime scenes. Certainly in the field, we have the responsibility of ensuring that it's properly packaged and labeled for the laboratory. So same kinds of techniques we've been using all along is that we're going to be very careful about loss of contents. We want to make sure that it's preserved so that it can't react on the way to the lab. We want to make sure we don't cross-contaminate it. We also need to be a little bit careful about safety of the person collecting it, especially with something like fentanyl, where in very small doses it can be absorbed through the skin and have a pharmacological effect. So the collector is actually in risk of themselves. So we want to be careful of that as well. The original container it was in would usually be the correct container to leave it in, so that we're doing as little, we're going to preserve it as it is. Oftentimes the field tests, we'll do field tests to kind of try to eliminate or give a rough answer of what we think it might be. Also, any paraphernalia found with it is again very similar. We talked about this a little bit in the physical evidence chapter, that we need to use an identification test on drugs. An identification test means really it has to be tested against many possibilities, and that's exhaustive and very time intensive and very expensive on laboratories. So if the number of possibilities can be reduced to just a few, that's very helpful to the lab technician. So paraphernalia based off of typical drug use can be very helpful for them to say, well, you know, this was found with a pipe, so it's very likely to be one of these substances. And that should be submitted along with the actual evidence, the drug evidence that's collected, to help the analysts make decisions about which analytical test to run. Again, we really talk about having kind of two different features. This is going to be an identification test that we're going to do, not a comparison test where we're seeing do they come from the same origin, but an identification test. You have to decide what chemical this is, and there are billions of possibilities. So trying to limit which test the lab analysis has to run is very helpful. Generally, there's two parts. There's the presumptive testing or a screening test, and sometimes that's done in the field, sometimes that's done on the lab, but it's very rough and preliminary. But the idea is to sort of knock out many possibilities so that we've reduced the possibilities of what this could be to a few, and then we can take just those few possibilities and run confirmational tests. So confirmational tests are going to be examples of tests where you're doing sort of a detailed analysis to truly identify exactly what compound it is. So in the presumptive testing or preliminary analysis, we're looking for ideas of what it might be. So the point would be, can I kind of get a guesstimate as to what I think it might be and get a partial test on that, so that then I can say, okay, great, I'm only going to run these 5 tests. It might be one of these 5 compounds instead of one of 1,000 compounds. And many times these presumptive testing, it can be done as color tests in the field. So in the field, we will do these different color tests. These are examples of reagents that can be mixed with the chemicals to try to determine an initial analysis of what it probably is or possibly is. And most of them are 1, 2, or 3 reagents that are added to the substance. We take a small sample of the suspected drug and add in a few reagents, and we're looking for a color change. We have a marquee test. Each of these will be a specific reagent called a marquee reagent or a Duquinol reagent. So the marquee test is a simple 1 reagent, and in the presence of heroin, it will turn purple, and in the presence of amphetamines, it's going to turn like an orangey brown. And then we have the Duquinol test, the Duquinol-Levine test. That's 3 different reagents. This one's a little bit more complicated, but in the presence of marijuana, there are 2 different layers, and one of the layers will be purple. The higher layer, there's like 2 layers, and one is the chloroform layer is the top layer, and that would be a purple color. The Scott test, again, 3 reagents. So it's 3 different chemicals that have to be added in a specific timed detail, and cocaine would return the reagent blue, and then back to pink when B is added. So we're going to first get a blue test when the first reagent is added, then it's going to turn to a pink test, and then when we add the third chemical, the blue color is going to move to the top layer. So it's a complicated sort of test, but a nice definitive test. And then we have the Dilley-Capagni test, which is for barbiturates that turns violet blue, and the Van Erck test, which has one reagent it tests for LSD and it turns blue purple. Unfortunately, with the Van Erck test, you have to have a fair substance. So LSD is a very potent drug and often found in very tiny quantities, and those quantities may not be enough to get a positive color test on. I will share a video that kind of shows an example of some of these, like in the field tests and how they're done. Essentially, they're sort of mimicking little beakers and test tubes and reagents in these nice field-based tests that can get you some preliminary answers. Another type of test, and this would be something that's done in the lab, is what we call a microcrystalline test. So instead of actually doing a chemical analysis on it, they're just looking at very great detail at the crystal structure. And certain drugs have certain size and shape crystals, so that we can mix it with a reagent and then look under a microscope at the crystalline structure and kind of get an idea of what it might be before we run chemical analysis tests. So once we've done that preliminary screening, then we can move on to the conformational determination. So this is a much more rigorous positive test where we're identifying the chemical. And once it's completed, we can say, yes, this is definitely cocaine. Yes, this is definitely LSD. So the idea would there would be a presumptive test, maybe in the field, maybe in the lab, to kind of get an idea of, yeah, we think we know what it is. And then you're only running the conformational test on a few, you're trying to confirm that it's marijuana or confirm that it's LSD, rather than trying to run chemical tests on any possibility of drugs. That's very expensive. So there's different specific tests for specific drugs. And the idea is it's going to exclude other chemicals and confirm that it matches the chemical that we think it is. So a couple of different ways we can do conformational determination. We're going to discuss the specifics of how these lab tests go. So in one case, so we can use a couple of spectroscopy methods and a couple of chromatography methods. So we have infrared spectroscopy is a very popular one, and also gas chromatography. Gas chromatography can be combined with mass spectroscopy, and we are going to talk about this in the next section. Just to kind of bring up these vocabulary words of qualitative versus quantitative. So one of the things that we would need to know, qualitative says, I can tell you what it is. Quantitative says, I can tell you how much of there is. And of course, as we know, some of the legalities and penalties talk about a certain quantity of substance. So when we're talking about an identification test, that's a qualitative test. Is this heroin or not? And then the quantitative test would be, how much is this? And again, we know that sometimes drugs can be mixed with other drugs, so you can't just weigh what you have and say you have this much, because it may be more pure or more cut and mixed with other things. And that's going to require doing some detailed analytical techniques in the lab of how much, what is the percent composition that you have of those components